Hello everyone. Today we are going to solve question number 11 from LeetCode named container with most water. So in this question, what you are given is you will be given an array. Yeah. In this array, we can visualize this array like this. Okay. So in this array, what you have to do is you have to find the two lines by which you can build a container which has the highest amount of water stored inside it. Okay. So basically what you have to do is find two lines that together with the x-axis form a container so that the container contains the most water. Okay. And in the end you have to return the maximum amount of water that you can store. Okay. And you can, there's a notice that you cannot slant the container. Okay. So it looks like this. So here the height had 1826 this array, and the final answer for this question is 49. So how it's 49 is we have 8 over here and we have 7 over here, and so the smaller height is 7. Okay, so the water cannot fill this part because obviously it will fall down. Okay, so this is like 7 is the height, and the width will be from 8 to 7. The index, we can subtract the index, so 1 2 3 4 5 6 7. Okay, so 7 into 7 is equal to 49. Okay, so this way the answer for this question is 49. Okay, so let's discuss the two approaches to solve this question. First one is brute force and second one will be two pointer. Okay, so let's see the brute force approach. Obviously, it takes off n square and it gives us time limit exceed for this solution. But let's discuss this how the question actually works. So demand of the question is to find the container with most water. Okay, so what you can see is the bottleneck of this question is that the the height with the smaller height. Okay, the compared to 8 7 is smaller. Okay, compared to 8 7 is smaller. So the 7 1 guides how much water we can store inside this container. Okay, same way, if in the starting we had 1 over here. Okay, we had 1 over here and we had 7. Okay, so between 1 and 7, 1 is the smaller one, so the water will be filled like this. Okay, and the only the one bottom level till height 1 it will be filled. Okay, so 2 points to uh, mark here that width can be calculated as j minus I. Okay, so j will be the index of one of these and second will be I. Okay, so j minus I will give us the width. Okay, and the second formula is the area is equal to width into minimum of height of left comma height of right. So height of left, oh yeah, height of right comma height of left. So among these, which one will be smaller will be the height of the container. Okay, so to solve this question using brute force approach, what we can do is we can initialize three variables: two to store height and width, and one to store the maximum water. Okay, so while iterating, we are going to store a user variable to store whatever the maximum value for max water we found. Okay, the next thing that we have is traverse over the array in nested format where I represents the start and j represents the end of the container. Okay, so let's say I started from here, so the j will start from here. Okay, so I starts from 1 and 8. We have space of 1 and we have height of 1. Okay, width of 1 and height of 1. So the value here is 1 into 1, that is equal to 1. Okay, so the 1 unit of water can be stored inside this container. Okay, so same way we are going to iterate j from this I plus 1 to n. Okay, and we'll calculate for this I, and then we'll move I forward. Okay, and then we'll re-evaluate max water through calculations. Okay, so let's code this one and then we'll see the second approach, the better approach to solve this question. Okay, first thing we need a utility int n is equal to height. Then we need one thing to store width, one thing to store max max water, and one thing to store height. Okay, so int h is equal to 0, int w is equal to 0, height represents by h, w representing width. Okay, and then int we need to store maximum water, so max water is equal to 0. Okay, now what we have to do is we have to use a loop in nested fashion. Okay, so for int I equals 0, I less than n, I plus plus. For int j equals I plus 1, j less than n, j plus plus. Now here we have to calculate three things. Okay, so the width will be w is equal to j minus I. Obviously j will be bigger than I, so we have to do j minus I. Okay, next thing that we have to do is to calculate height, we have to use minimum value of height of I comma height of j. So we already know why we are picking minimum is because the bottleneck is that smaller height I is controlling the amount of water that can be held inside this container. Okay, hence we are doing minimum here. Then we have to do a max water is equal to max of max water if the answer already exists, or width into height. Okay, so this way we are going to update our max water, and then in the end we have to return max water according to question. Okay, so let's run this and let's submit this. So we got a TLE over. Okay, so basically the values inside the height were too big to calculate over here, so we got a time limit exceed because obviously our solution is of O of n square, so it takes quadratic times complexity. Okay, so let's try to optimize this solution. Now what we have to do is we can use another method to solve this question, which will be two-pointer approach. Okay, so what you have to do in two-pointer approach is we have to utilize uh, the width and height smartly. Okay, so the same insights here. The water level is limited by the shorter line. Okay, the shorter line limits the water level. So to increase the area, we must try to find a taller line on the smaller side. Okay, so let's say if in place of this 3 we had 10 over here. Okay, or 10 or 12 over here, then drastically the amount of water that can be stored will increase. Okay, the amount of water that can be stored will increase. So the steps to calculate in this two-pointer approach will be, first you will initialize two variable L and R. Okay, L pointing here, R pointing here. While L is less than R, we'll compute area, we'll update maximum, and then we'll move pointer with smaller height. Okay, since we know that the bottleneck is the smaller height, we're going to move it, not the this one, the taller one. We are going to move shorter one. For each iteration we are going to move the shorter one. Okay, and then in the end we have to return max. Okay, so why we move the pointer with smaller height, we sacrifice with in hope for increasing the limited height. Okay, so as I said that there's a chance that rather than 7, here it can be 12 or 15, and here also we can get 12 or 15, and then the amount of water that can be stored would be larger than the current one. Okay, so here you can see if height of L is less than height of R, then current area is this. So the bottleneck is our height of L. So even if we move r, the height is still limited by height of L. So moving r is basically useless. Okay. So the only hope here is to move L. Okay. So let's see the visuals of how actually this two pointer approach is working. Okay. So first you can see in this array, okay, this same array, what you can see, the area is 1 because 1 is, this is the limiting factor, 1 height into 8 as our width. Okay. Width is r minus L. Okay. So here you can see current maximum is 8. We know that 1 is our limiting factor, so we're going to move L plus plus. Okay. Now we reached 8. Okay. Now we can calculate as 7 from width, and 7, this r here is our limiting factor. So 7 into 7 is 49. So our max is updated to 49. And then we're going to check the condition again, but this time height of L is greater than 8 is greater than 7. Hence we are going to do r minus minus. Okay. So the r pointer will move towards the left side. Next, we will be having r at 3, and then calculate again. It will be 18. Max is 49, so it's not updated. Now we again saw that this is our limiting factor, so we are going to move this. Same here, we have both sides, we had 8. Okay. Then we again calculate the area. 8 5s are 40, so we got 49 as our max. It didn't change, so hence we again do r minus minus. Okay, this is choice of design. Both were same, 8 and 8. I just moved r. Okay, you can also move L, it doesn't change the answer. Okay. Next, we again had same thing. Bottleneck was 4, then we calculated 16. Width was also 4. Okay, again 16 less than 49. Again we moved again ahead for r minus minus. Okay. Then we reach 5. 5 is a 15. um, Again the bottleneck was 5, so move again, and this way we traverse the whole array. Okay. In the end we reached till this part, and then we had a condition above. Here we had condition L is less than r, so our while loop stops. Okay. And as you can see, once after uh, getting 49, the value never changed. Okay, it stayed 49 till the end. Okay, so this is the way you can solve this question using two pointer approach. Okay, so let's code this one and then see. Okay, so what you have to do is, int, we need first a utility int n is equal to nums dot, okay, height dot size. Then we need a left pointer is equal to 0, and right pointer is equal to n minus 1. Then we'll iterate over this array. Okay. And we also need something to store the maximum water, right? So int max water is equal to 0. Then for int I equals 0, I less than n, I plus plus. Now what you have to do is we have to do these 3 steps. First compute area, update max, move pointer, right? So to calculate the amount of the area, we have to use int area is equal to r minus L, which is a width, into minimum value of height of I. Oh, sorry, I use for loop. I have to use while loop. Okay, I have to use condition base while L is less than R. Yeah, this is correct. Now, while L is less than R, then we have to do minimum of height of L, comma, height of R. Uh, so this way we have calculated area. Now we have to update max. So max water is equal to maximum, or maximum value of max water if it's already there, like we saw in 49. Okay, or area. the newly calculated area. Okay. Now the bottleneck was the left side or the right side. Okay. Then what you have to do is if height of left is less than height of right. So basically this means the left side is a bottleneck. Okay. Then what you have to do is you have to do L plus plus. Okay. Else I'm going to do minus minus. Okay. So this is simple part. We recalculated area. We updated max water if it was greater than previous version. Then we just updated height value, right? So after this, we have to just return max water. Okay. So you can see this is a greedy approach because greedily we are choosing between L and R. Okay. If L is smaller, then we are choosing to increase L. If R is smaller, we're trying to increase R. Okay. So let's run this. Let's submit this. And you can see the question is done. Obviously, it ticks off and time complexity. Okay. So that's it for today's video. Thank you for watching.